gradient intercept form, I'm showing you an alternative method. You could use the table method on the previous page, but you can also use this alternative method when you have gradient intercept form. So remembering that y equals mx plus c, just a reminder, m is the gradient. What is the c? That's right, it's the y-intercept. So as I was just going on about, we could either use the table method on the previous page, like, x-intercept, y-intercept, or in this form, we can plot the value of the y-intercept first, and then use the gradient, m, to plot several other points. So below I'm going to point out how you can do that. So for example, sketch y equals 2x minus 5. That's in gradient intercept form. What's the value of the y-intercept? There you go. Is it positive 5? Is it? No, it's negative 5. Don't forget the sign. So plot this on the graph now. Plot the y-intercept of negative 5. Let's do that in blue. See, down the bottom, not at positive 5, at negative 5. Tick, done. Then express the gradient as a fraction. So what is the gradient according to our green equation? What's our gradient equal to? Is it x? No, it's 2. So 2 is the gradient. It's the coefficient of the x term is our gradient. How would you express 2 as a fraction? Try to think. 2 is the same as... You just ignore that. I tried to write the number 2 over the top. So 2 is the same as... That's right, 2 over 1. Oops, I wanted to do it in a different colour. So I want to do it in green. So 2 over 1. 2 is the same as 2 over 1. So we have a rise of 2 and a run of 1. So from your y-intercept, our y-intercept is that blue point at negative 5. Go up by 2 and across by 1, because it's a rise of 2 and a run of 1. So from the blue point, little blue point I've marked, see with my green pen, I'm going to go up 2 and across 1. There you go, there's my second point. Tick, done. Then from this point we just made, go up by 2 and across by 1 again. We're using the gradient to plot more points. And plot a third point. So see I went up by 2 across by 1 and so on. Go up by 2 across by 1, up by 2 across by 1. Magic. Up by 2 across by 1. We can similarly from the y-intercept go down 2 across 1 to continue on the pattern. Now rule a line connecting these points. And don't forget to label your line with the equation as well. Very, very important. So now we're going to rule a line. Going to make sure the line goes through all the points. So yeah, make sure it goes through all the points properly. I'm just going to need to adjust mine again. So just feel free to watch while I adjust. It doesn't see at the top points. Yep, now it's better. It's going through all the points now. What's it missing? My line is missing something very important. I'm missing the equation. That's right. Y equals 2x minus 5. So label it somewhere. Y equals 2x minus 5. Let's not give anyone any reason not to give us full marks. So make sure to label your lines. And I'm going to save my file right now. So that's pretty straightforward, but we might need another example to get the hang of it. Sketch the line y equals negative x plus 4. So it's in gradient intercept form. So what's the y-intercept? It's the constant term. That's right, it's positive 4. So let's plot that y-intercept on the graph now. So there's our 4, tick, done. Then express the gradient as a fraction. So our gradient is it negative x, our gradient? No, it's not. What is the value of the gradient equal to? Good, negative 1. So now then let's express this gradient as a fraction. Negative 1 expressed as a fraction is the same as negative 1 divided by 1, because a negative divided by positive is a negative. So we can say we have a rise of negative 1, going down by 1 basically, and a run of 1. So from your y-intercept, which is a red point, go instead, because it's a rise of negative 1, go down by 1 and across by 1. So from your y-intercept, let's go down by 1 and across by 1 to plot a second point. So as I said, this is an alternative method for graphing. Some people find this a bit faster, but you just need to have gradient intercept form first. Down by 1, across by 1. Now from that point that you just made, go down 1 and across by 1 again to plot a third point. Down by 1, across by 1, there's our third point. Oh, soup in a sandwich. And continue on, down by 1, across by 1. Down by 1, across by 1. Down by 1, across by 1. Do you want to do another one? Yeah. And remember, from the y-intercept in red, we could also have gone up by 1 and backwards by 1, up by 1, backwards by 1. See, it just follows the pattern. Brilliant. Now let's rule a line and connect these all up, as I remind you to do down the bottom. So then I rule a line, connecting these points. And what do you need to put on that line after you've drawn it? That's right, you need to put the label. So watch me rule my line in lilac. Oh, that's pretty good. That's not bad. First go. What am I missing? Why might someone take a point off? To be mean. That's right, I'm missing the equation. So don't forget to label your line. You need to play defense and not give anyone any reason to take a mark off. Negative x plus 4y equals negative x plus 4. Write the whole equation. There you go, that one's done. Let's save our